Hello everyone, myself Harshvas with my fellow teammates namely Prem Swaroop, Manuel George, Balasurya M and Malin Shah are going to present on the topic deep reinforcement learning to train locomotive activity in robots. This project is done under the mentorship of Ms. Surabhi Gupta on behalf of leading India AI at Bennett University. Deep reinforcement learning uses deep learning and reinforcement learning principles to create an efficient algorithm applied on areas like robotics, video games, computer vision, education, transportation, and healthcare. Implementing deep reinforcement neural networks with reinforcement learning algorithms, we are capable of scaling and solving the previously unsolvable problems.
Hello, my name is Prem Swaroop Satsangi. In the very beginning, we built our foundation of reinforcement learning from YouTube. We learned about Bellman equation, Markov decision process, Q-learning, deep Q networks, and concepts of exploration and exploitation, by which we implemented the Frozen Lake with Gym library, which has a lot of collection of environments for simulation. After understanding the fundamentals of reinforcement learning, we moved towards more advanced reinforcement learning algorithms like SAC, DDPG, TD3 and PPO, etc. Using these algorithms, we trained our models mostly for 1 million time steps and plotted the graphs of rewards achieved with respect to the time steps to observe the learning process of the algorithms, and they were not satisfactory. And there we came across hyperparameter tuning, which improved the performance of our algorithm phenomenally. Agents in the environments were learning faster and performing better locomotions after hyperparameter tuning. We learned a lot. Thank you.
Hi, my name is Manuel George Thomas. I'm going to talk about the algorithm that we have implemented called Stop Actor Critic algorithm, also called as SAC. SAC is a deep reinforcement algorithm with a state-of-the-art performance and continuous control environment. SAC is based on maximum entropy reinforcement learning, a framework that aims to both maximize the expected reward and maximize the policy entropy. SAC is an off-policy algorithm. SAC uses the concept of maximum entropy learning, which encourages the exploration of new states, improving the translational data collection. It also prevents the premature convergence to bad local optima. We have implemented the SAC algorithm in two environments. One is a bipedal walker in Box2D. Half cheetah in MuJoCo. MuJoCo is a continuous control task running for fast physics simulator, which was made by OpenAI for open source. Now we can see the graph resultant we have got. After the implementation of SAC algorithm, we can see that the graph both the agents were trained up to 1 million steps. We can see that the variation of reward in the graphs, and we can see and compare how the algorithms work in different environments. Bipedal walker has a reward range of 300 as it is in a 2D environment. Half cheetah has the reward range of 500. They have high rate of reward compared to other algorithms because they have maximum entropy learning.
Hi everyone, I'm Balasurya. We have used one of the most powerful and state-of-the-art algorithms known as Twin Delay Deep Deterministic Policy Gradient, or shortly known as TD3. TD3 is introduced as an improvement to the DDPG algorithm. DDPG was one of the most used algorithms for continuous control tasks such as robotics. DDPG has its drawback of overestimating the Q value and heavily relying upon its hyperparameters. TD3 solved this problem by using two critic networks instead of just one and introducing action noise regularization. Let's have a look at the results. We can clearly see that TD3 outperforms SAC. The learning curve shows the rewards earned by the agent for a total of 1 million time steps. Even though the agent starts performing very poorly, it learns how to interact with the environment, performing very good, earning good rewards from 6 lakh time steps.
Hello everyone, my name is Malansha and we would like to take this opportunity to thank our mentor from Bennett University, Professor Surabhi Gupta, for helping us throughout this complete internship, and she has also helped us to solve all the various hurdles that we have faced during the internship. Since this problem was really very new for us, we have faced really very hard, difficult problems, but we have overcome them and successfully completed the project. We would finally like to thank the complete community of Leading India and Bennett University for providing us this platform to learn and grow.